Okay, so welcome everyone. Welcome to my channel. Yeah, please continue supporting my page by subscribing, inviting more friends. Also, try to answer as many questions as possible. Yeah, so I always say, if you have a problem, you have a challenge, you can reach out where you feel like I didn't explain much. You can always reach out to me, and also yeah, so you can consult other books. It's not like this is the only material available out there. There are a lot of things. Yeah, so you can combine what you learn in class. So my page is all about re-emphasizing what you learn in class. Maybe in class, lectures, maybe they might be too busy explaining some other things. Yeah, so that's what my page is all about. So we are learning from each other. So continue liking my page, share my videos, invite your families, and let's learn together. Okay, so thank you. So today, like I mentioned last time, there are times where you can't use, so for those who follow nicely, there are what we call methods of integration. So integration, we talked about substitution method. We also talked about a quotient. Yeah, so the quotient. What do I spell quotient? I don't know. Okay, quotient rule, something like this. Then the other one was by partial fractions. Partial fractions decomposition. Okay, so today we'll look at the last part of integration, which is integration by parts. Okay, so if you have not followed, or if you've not watched these videos, just go to the videos, my previous videos, and watch. Make sure you understand how to employ substitution method, how to employ the quotient method, how to employ the partial fraction decomposition. So all these are methods of integration. So today we only focus on integration by parts. So if you see these questions which are here, somehow you can't use substitution method, it can't work. You can't use quotient rule. Quotient rule works only when you have fractions, it can't work here. And partial fractions also deals with fractions with multiple linear functions, so it can't work. Then how do we solve? So today now, that's where we have to cover our last part of integration, which is integration by parts. So how do we use integration by parts? Okay, so integration by parts uses the formula. So integration, so you have u dv equals to uv minus v du. Okay, so basically this is the formula which you have to know. So you start with u. So when you see, you only have two letters here, u and v. So when you write u, meaning the derivative part is what? V. Then you have u, v minus, when you write v, you know that the derivative part will be what? U. Yeah, so if you write u, meaning this part will be v. If you write v, meaning this part will be u. So at least this will help you remember. So how do we employ this formula? So one, if you're given an equation, so if you see here, you have u and dv. So how do you know which one should be u and which one should be dv? So u, for example, write a function equals to u, and then dv. dv is a function which you are going to integrate, so you are going to integrate this. So if you integrate dv, what are you going to have? You have v. Okay, yeah, then you're going to differentiate u. So you have u and du. Yeah, so the function which is, so how you decide is this way. If you're given a function, it will have maybe, let's say x squared cos x dx. Which one do you pick to be? So here we have to pick which one is our u and which one is our dv. So you pick a function which is easy to differentiate, and then v, your dv, will be the part which one, the function which is easy to integrate. So there are complex questions where you can't just pick this is my u, this is my dv. So the one which is easy to integrate, you set it equal to what? dv. Then the one which is easy to differentiate, so I said dv easy to integrate. Okay, so u easy to differentiate. Okay, so this is how you pick the one which you see, this one, integrating it is easy. You set it equals to what? dv. Then you see, oh, this one is very easy to differentiate. You pick it equals to what? u. Okay, so that's the tricky part of this formula. It's very easy. Just know which one should be dv. The one which you see is easy to integrate will be your dv. Then the one which is easy to differentiate will be what? u. Okay, so I think we will best understand if we do, let's do an example. Let's answer these questions for you guys to see what I'm talking about. Okay, so I'm just rewriting these questions. So we have a, so we have integral x sine x dx. So this one is very easy. We know x is easy to integrate, it's easy to differentiate. Sine is also easy to differentiate, it's also easy to integrate. So here, no need of struggling which one should be u, which one should be dv. Just say, for example, u equals to x. Simple. Because everything is simple here. All these examples, no need to panic about which one should be your dv, which one should be. You just set in. So you have two parts. You have this part and this part. So you set one equal to u. Because our formula is u dv should be equal to uv minus v du. Okay, so x is, so we say u is equals to x. Then what is du? How do we write du? Du, we are differentiating with respect to x. So if we differentiate this du, we differentiate this with respect to x, the same as the du dx. So x, differentiating x, we bring down the power. If you remember, differentiating is n minus 1. So here the power of x is what? 1. So it's 1 multiplied by x, then power is 1 minus 1. Okay, this is your du dx. We are differentiating with respect to differentiating u with respect to x. So du dx is equals to, so this is 1, 1 minus 1 is 0, so anything raised to power 0, you know, is 1, so it's 1 by 1. Anything raised to power 0 is 1, so this is just equal to, so du over dx is equals to 1. So you know this is over 1, you can cross multiply, meaning du is equals to dx. Okay, du is equals to dx. So you are going to put where there is du, you know, here this part is du, this part is du. Okay, so du, we know what du is. Du is just same as dx. Okay, so then let's pick our dv. So the next part is dv is equals to sine x. So we know this one, it has dv, so we have to integrate it. Okay, so dv equal to sine x, so you integrate. So when you integrate dv to be v, integral of sine is what? So if you integrate sine, what is it going to give you? Negative cos x. Of course it will have a plus c, but at this point we are not bothered about plus c, so v equal to negative cos x. So we have our u, which is this one. We have our v, which we have calculated after integrating the dv part, and we also have our du here. So now let's apply the formula. So the formula is integral u dv is equals to u v minus integral v du. Okay, so what is u here? This is same as the question you have been given. Okay, so this is the x sine x. Okay, this is your question which you have been given, dx. So because here we know dv is same as dx, I mean, sorry. Dv is just sine x. Okay. No need of writing. In short, I'm just saying we are integrating this function. Okay, so this is the function here, which should be equal to, what is u? So u, we had said u is x. What is v? V is negative. I've written like it's a minus, so let me do this. Okay, so yeah, so you have v, so you have u, which is this one, then v, which is negative cos x, close bracket, minus integral, what is v? V is negative cos x. Then what is du? What is du, this part? Du is here, du is same as dx, so we just write dx. Okay, so equal to, this is same as negative x cos x. The negative can come outside, we know that, we discussed from our previous videos. So negative multiplied by negative, it will be positive, so here we'll have a positive cos x dx. Okay, So this is negative x cos x plus, then what is the integral of cos x? It's just sine x. So also add the plus c. So this is your answer. So I love first starting with the positive, so I can just write sine x minus x cos x plus c. Okay, so the integral of x sine x dx is this. Very simple and straightforward. So in case you didn't follow, let's do another example, so kindly follow through. Okay, so b, so we have integrate x e to the power 2x. Okay, so dx. So even this one is very easy. You can just pick whichever to be du, whichever to be dy. Questions which they give you guys are very simple, so you don't need to bother which one is du. Just know how to use the formula. So you say u, one should be u. So this one, you can say which one is easy to differentiate. Okay, let's pick this part to be u, 2x. Okay, so meaning if you differentiate u with respect to x, du dx is equals to, so for e to the power anything, you know, we get this coefficient, we drop the coefficient. Yeah, so we just drop the coefficient down. That's how you differentiate this e, because if you say e to the power x, the coefficient is 1, so if you differentiate this, it will be just e to the power x, because the coefficient here is 1, so 1 multiplied by e to the power x is just e to the power x. So this, we just get the coefficient here, so it will be 2 e to the power 2x. That's differentiating d over dx. So if you differentiate e, so let's say e to the power 3x, you are differentiating this the same as, you just get the coefficient to be 3 e 3x, like that. So if it's e to the power 4x, we differentiate to be 4 e to the power 4x. Okay, so I've emphasized that point. So now differentiating this is same as, we have 2 e to the power 2x. So here we want du. So let me write properly. So you have du over dx equal to 2e to the power 2x. Okay, so this is over 1, you know that. Then you can cross multiply, dx multiplied by this, du multiplied by 1. So du is equals to 2e dx. Okay, so we know our du is this. Then you say dv now. dv is equals to what? What is dv? dv will be this term here, x. Okay, so the one which you pick to be dv, you are integrating. So dv equal to x. So you integrate both sides. So if you integrate dv, it's just v. So if you integrate dv, it will be just v equal to, then integration x, integrating x is just 1 plus 1 over 1 plus 1. Okay, so v equal to x squared over 2. So now we have du, we have v, we have dv, we have u, and then we have u here. So we now apply the formula. So integral u dv equals to u v minus v du equal to, so what is u? U, we've set it equals to here. U, we've said this one, okay? Multiplied by, what is v? V is this one here. So we have x squared over 2. You're multiplying minus, what is v? V is x squared over 2. And then multiplied by, what is du? What is du? So du is 2e to x. This dx. So let's have some cleanup. So we have x squared e to x. This is over 2 minus, so 2 and 2 cancel, so we have x squared e to the power 2x dx. Okay, so we have this. Okay, so we have this. Then what do you do next? So again here we formed again another equation. So which also will require us to use, to implement another function. Okay, so you also integrate this part, which you have to apply again this same formula. You set du dx like that, du dx as well. So yeah, that's what you do. So here we implement this formula again. Yes, so for the second time again you set which one is your u, which one is your dv. Yes, so we have x squared e to the power 2x over 2 minus, so this is integral x squared e to the power 2x. So let's see. So I want to show you guys something. So which one of our dv? Okay, so yeah, this point is what I mostly emphasized, like the point, if you, those who followed through at the very beginning, which one should be your u and which one should be your dv. So I said the one which you are, which is very easy to integrate, the one which is easy to integrate is what you pick to be your dv, and the one which is easy to differentiate should be what? Your u. So you've seen here we picked our u. Okay, let me quickly go back. So we picked our u as, so our equation is let's say, let me write it again. So it's like x e to the power 2x dx. Okay, so I picked this as e to the power 2x, then this as e x. So let's see now what I was emphasizing. So the whole point why we use this formula is to make the equation look simple. So if you see here, if you integrate this, you are increasing the power of x, meaning you are making the equation more complex. So that's what I deliberately to some degree picked this for you guys to see. Oh, if you pick a wrong u and the wrong dv, what happens? So our dv now, if you integrate, because the dv you integrate, so dv equals to x. So if you integrate this and integrate this will be v. You are increasing the power of x, making the equation more complex. So you are not supposed to increase the power. You're always supposed to reduce the power. Okay, so yeah, so bear in mind that it's not only which one is easy to integrate and which one is easy to differentiate. You look at, if I pick this one, am I making the equation simpler or more difficult? So if you've seen, this is x. If you integrate it, you're taking the power up, meaning we're making the equation more complex. So you just have to bear in mind that, like this, because the dv, I've said you have to integrate it to get v. So when you integrate and the power goes up, or divide by 2 here. So if you integrate, the power goes up, you're making the equation more complex. So meaning you've picked the wrong dv and the wrong du. So meaning u should be x and dv should be e to the power 2x. So that if you differentiate this, differentiating this du over dx, it will be just 1. We showed how to differentiate a function, so I'll just write. So you bring down the power from our previous example, those were following. I've said you bring down the power, then or you bring down the power, yes, and then subtract the power by 1. That's the procedure. So you bring down the power and subtract by 1. Let me use a different marker now. So you were saying this is x, it's power 1. It doesn't write properly. Just stick to that. Okay. Okay, so this is just 1 multiplied by x, 1 minus 1. So du over dx is equals to 1. Anything raised to power 0, so 1 minus 1 is 0, x power 0 is 1, so 1. So du over dx is equals to 1. And this is over 1, you cross multiply. Okay? So this is just to tell you that du is equals to dx. Because dx multiplied by 1 is dx, du multiplied by 1 is du. So this, you know that the equation is becoming simpler when you see something like this. Then we say dv is equals to e to the power 2x. So when you integrate both sides, v is equals to integrating e to the power ax. If you integrate, you get 1 over a, e to the power ax. Okay, so the coefficient of x is what? 2. So it's 1 over 2 e raised to the power 2x. Okay, that is the integral. So plus c, but no need of plus c. We are still on the way. Okay, so we know v is this. We know du is this. So u dv equals to, so this is the integral, uv minus v du. Okay, so let's substitute our equation. What is v? What is u? U is what? X. And what is v? V is 1 over 2 multiplied by 1 over 2 e to the power 2x. Okay, minus, what is v? What is v? V is half e to the power 2x. multiplied by what is du. Du is same as dx, so just write dx. Okay, so you've seen that this one has become simple. So let me just get some more room. U dv equals to, so this multiplied by this to be x e to the power 2x, everything over 2 minus, I'll take half outside, so we'll have half integral e over 2x dx. Okay, so integrating this is simple. I just showed it up here, how to integrate e to the power a number. So just quickly, okay, so this is x to the power 2x over 2 minus half. So integrating this is 1 over 2 e to the power 2x, so plus c now. Okay, this is same as, so we have a half here, 1 over 2, we can take it outside, 1 over 2, so here we'll have x e to the power 2x minus, there will be half here again, e to the power 2x over 2, this one, plus c. Okay, e to the power 2x is also common, we take it out. Okay, so we can take it out, so we have 1 over 2 e to the power 2x, so here there will be just x, minus here there will be just half, plus c. Okay, so this is your answer, x e to the power 2x dx. Okay, so hope you guys have seen the emphasis I was making. We picked the wrong du and dx, and then in the end we ran into problems where we made the powers here. Again, we have to employ this formula for the second time on this part. Of course, there are questions which go like that, but you just have to check your du, check your dv properly. If you see that it's becoming more complex, meaning you've picked the wrong du and the dx, so you have to quickly reverse what you had picked. So let's come to this one. Let's come to c. So c, okay, c, so for c, we're integrating x cos x dx. So here, which one do we pick as u and d? How do we reduce this power? So the only thing which you have to be concerned with, how do you reduce this power? You can only reduce by differentiation. So meaning you pick u to be x, then dv as cos x. Then integrate this. You are differentiating. You find du dx. So du dx, differentiating u with respect to x. So this, the power is 1, so 1 multiplied by x, 1 minus 1. Okay, so du over dx is equals to, which is 1. Anything raised to power 0 is 1, so we have differentiated this for multiple times, meaning du over dx is equals to 1. So this is over 1, you can cross multiply this to be du is equals to dx. Okay, nice. Then we come to this, dv equals to cos x. So here you are integrating. So v equals to sine x plus c, but it doesn't matter. Okay, so now we write the formula u dv equals to vu minus v du. Okay, so this, what is v? sine x multiplied by, what is u? U is what? X minus, what is v? V is sine x. And what is du? Du is just dx. Okay. Okay, so you say equal to, is my pen not writing? Oh, okay. So we have here equal to, so this is x sine x minus, so what is the integral of sine x? It's negative cos x plus c. This is x and sine x, negative multiplied by negative, positive cos x plus c. So integral of x cos x dx is equals to this. Very simple and straightforward. Okay, so let's solve the last part and see how we to run us to. Okay, so this one, okay, so before you start solving, how do you reduce this power here? Is by differentiating. So your u is x squared, then differentiate now, so du over dx, differentiating u with respect to x equal to, so I've said x to the power n. If you are differentiating, is same as n x n minus 1. Okay, so you bring down the 2, come here, x 2 minus 1. Okay, so du over dx is equals to 2x, 2 minus 1, it will be just 1, so we don't write 1. So this is over 1. We want to get du and dx separate, so we cross multiply, du multiplied by 1, it will be du, and dx multiplied by 2x, it will be 2x dx. Okay, we have 2x dx. Nice. Then now let's get dv. So dv is what? Sine x. So how do we get v? We integrate. So we say dv equals to sine x. So we integrate. V is equals to negative cosine x or c. Okay. So now let's employ the formula. The formula is u dv equals to uv minus v du. Okay, so what is u? So u is x squared. Okay, u is x squared. What is v? V is negative cos x. Okay, minus, what is your v? V is what? V is what? Negative cos x. And then what is du? Du is what? 2x dx. 2x dx. Okay, so let's continue. So this is x squared, and just take the negative here this side. Okay, cos x, negative and negative, it will be plus. Okay, so we take it out already. We have 2x cos x dx. Okay, so you see, we don't have higher powers here. We are in the right track, but we apply this formula 2 times because we have reached here and we know we are not doing anything. We have not done anything. Okay, so you have x squared cos x plus, so we can take out the 2 so that we just remain with x cos x dx. Yeah, so here we can't integrate again because it's complex, it's multiplication. So here, this part now, we also have to do what? apply the integration by parts for the second time now. So yeah, so we'll take it up. We just get in this part. Okay, so let's say we are integrating x cos x dx. Okay, so which one is your u? We are trying to reduce this power, so u is x. Okay, yeah, by now you know that we are trying to reduce this power here. So how did we know that we are in the right track? The power here is not increasing. If the power increases, just to know that you are in a wrong track. The power here didn't increase. You see? The power was power 2, but in the question it was power 2, but now it's 1. So we are in the right track. Okay, so now what we do, we differentiate with respect to u. So du over dx is equals to, so if you differentiate this guy, you have 1 multiplied by x, 1 minus 1. Okay, so I've differentiated this for a long time. I've differentiated it, I mean, for multiple times now. So you just have to know differentiating x is just 1. Du over dx is 1. Okay, so over 1, cross multiply this by this, so meaning du is equals to dx. Okay, then now let's get our dv. Our dv is what? Cos x. So dv equals to cos x. So we are integrating. Oops. Okay, get rid of it. Integrating. Okay, so integrating dv, we have v. Integrating cosine is just sine x plus c, but this is no need of writing plus c. Okay, yeah, just use writing plus c. Okay. So you have integral u dv equals to u v minus v du. Okay, so let's put our things together. We have our u. What is u? U is x. V is sine x. Minus, what is v? V is sine x. And what is du? Du is dx. So this is just dx. Okay, so let's now we solve this one to be x sine x minus, what is the integral of sine? It's negative cosine x. So x, so this is x sine x, this by this, plus cosine x plus c. So you remember, this is the second part. This is just this part here. We're following through. Where is the work? I seem to find my work. What's happening? Okay, what's happening? This application keeps freezing. Okay, so it's this part. So let's write, let me just try to copy. Can I copy this? Okay, let me copy this now. So I'm going to put this side, his part we've solved now. So we have the answer for that part now. So paste it. Let me just give it a few seconds. So hope you guys understanding these things. So okay, so we had negative x squared cos x plus 2, then there was the integral of x cos x dx. Okay, so we solved this part, which is the answer here. So meaning our answer now is negative x squared cos x plus 2 open bracket. So we are putting this side, this one. Okay, so make a sine x, x sine x okay, so here is closed. Okay, so here now I'll write the answer for this part, which is x sine x plus cos x. So after writing this now, that's when you can put the plus c. Yeah, so let's write it nicely. It's nicely x squared cos x plus 2x sine x plus 2 cos x plus c. Okay, so let's see which one can we combine. Okay, we have this part and this part. So we can combine those, I think. So we can take out the cosine. So cos x open bracket, this will be 2, just 2, and minus x squared, this one here, and then plus 2x sine x plus c. Okay, so this is our final answer. So integral x squared, let me just quickly put it. Okay, simplification. Behaving badly. I apologize for that. Okay, so we have finished, guys. So just know that there are times where you have to apply the so this is D. Actually, I forgot to write this is D. Okay, this part. So there are times where you have to apply this integration by parts twice for you to get the answer. So it was x squared sine. Okay, so let me just write quickly. Sine x then equal to, this is equals to cos x times x squared plus 2x sine x plus c. Okay, so this is your answer. Okay, so thank you guys for watching. Continue watching my videos, invite your friends, invite your family members. Okay, so keep subscribing and also keep suggesting more questions to be solved. So this marks the end of integration. So we did integration, substitution method, integration through partial fractions, and then integration by parts. So this concludes our part for integration. So thank you. Hope you've enjoyed the lesson.